You're listening to the N2K Space Network.
The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
No lie, we sat in our morning editorial meeting today watching anxiously as the ULA Atlas V rocket with Boeing's Starliner crew capsule on top, carrying Sunny Williams and Butch Wilmore, readied to launch from Florida. And the team's consensus was that today had to be the day for them. We all willed a good takeoff and flight for all the teams involved. And finally, the third time's the charm for the Boeing Starliner crewed flight.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is June 5th, 2024. I'm Maria Varmazis, and this is T-minus. Starliner launches its first crewed flight. Rocket Lab completes the second launch of pre-fire. The FAA approves a fourth test flight for Starship. And our guest today is Paul Bagdanove, Webb Telescope Mechanical Systems Engineer at KBR. Paul shares his insights into his work as a contractor for NASA on both the Hubble and James Webb Space Telescopes. So stay with us for that chat. It's Wednesday, everybody. Let's get into it. And they did it with a sigh of relief heard around the world today. It's a great start to our show with the news that Boeing's Starliner successfully lifted off from Cape Canaveral Space Force Base in Florida this morning atop a ULA Atlas V rocket. Third time is indeed the charm for Starliner. It's Starliner's third overall orbital flight, and today was also the third launch attempt for its first crewed test. And it was a picture-perfect launch by all accounts, with the launch vehicle and crew capsule passing through all major milestones during launch, all the way through Starliner's separation from the rocket and arrival into a stable Earth orbit. So, congratulations are in order for the NASA, Boeing, and ULA teams for today's success. And all the best to Butch Wilmore and Sunny Williams as they continue their test flight. Starliner's launch success is a big step for NASA's commercial crew program. And should the entire crew test flight be deemed a success, NASA with Starliner will finally have 2 certified rides to the International Space Station, one being from SpaceX and the other, fingers crossed, from Boeing. But let's not get ahead of ourselves just yet. Starliner's crew flight test is still ongoing, with Butch and Sunny on their way over the next day to the International Space Station, where they'll be arriving and docking with the Harmony module around noon Eastern tomorrow, June 6th. And oh yeah, there's something else launch-related going on tomorrow. You might have heard. SpaceX's Starship got the FAA license reauthorization it needed to launch, and SpaceX is targeting a June 6th, 7 a.m. Central Time launch for flight test number 4. And again, that is tomorrow. The FAA released a statement saying that SpaceX met all safety and other licensing requirements for this test flight, and as part of its request for license modification, SpaceX proposed 3 scenarios involving the Starship entry that would not require an investigation in the event of the loss of the vehicle. It's worth noting that after evaluating them as part of the flight safety and flight hazard analyses, the FAA approved these scenarios as test-induced damage exceptions and confirmed that they met public safety requirements. This update could potentially speed up the cadence of future flight tests, but if a different anomaly occurs with the Starship vehicle, well, an investigation may still be warranted. So, tomorrow morning, 7 a.m. CST, keep an eye on Boca Chica, Texas. Excitement is guaranteed. And continuing with the launch news, Rocket Lab successfully completed the second of 2 back-to-back launches on Electron for NASA's latest climate science mission called PREFIRE. The mission PREFIRE and ICE deployed the second of 2 satellites for NASA, and the first mission, which was called Ready Aim PREFIRE, was successfully launched just 11 days earlier on May 25th from the same launch site in New Zealand. The satellites will crisscross the Arctic and Antarctic to study heat lost to space from the Earth's polar regions. The measurements collected by the PREFIRE mission will help to improve climate and ice loss models to better predict Earth's ice, sea level, and weather changes. We shared the story yesterday that the Hubble telescope was dealing with issues with one of its gyroscopes again, and that NASA had called a press conference on it. A small part of us thought it might be the announcement that the U.S. Space Agency was going to accept the help of billionaire Jared Isaacman, who has offered to pay for a mission to repair the troubled space telescope. But alas, after a thorough review, NASA says that offer, while generous, could cause more problems than it might try to solve, and as such has been firmly rejected. Instead, NASA gathered the media to announce that work is underway to transition Hubble to operate using only 1 gyroscope of its 3. Hubble will remain in safe mode until the work is complete. Firefly Aerospace has signed a multi-launch agreement with Lockheed Martin for 25 launches on Firefly's Alpha rocket through 2029. This agreement commits Lockheed Martin to 15 launch reservations and 10 optional launches. Under the agreement, Alpha will launch Lockheed Martin spacecraft into low Earth orbit from Firefly's facilities on both the West and East Coast. The first mission will launch on Alpha Flight 6 from Firefly's launch site at the Vandenberg Space Force Base later this year. True Anomaly has been awarded a $1.6 million direct-to-phase 2 contract by SpaceWorks, focused on tactically responsive space, also known as TACRS. The company will be tasked to expand the capabilities of the company's Jackal autonomous orbital vehicle to meet the demanding requirements of the TACRS mission set. True Anomaly will deliver rapid payload integration, the demonstration of increased capability in the Jackal AOV responsive propulsion system, and advancement of the baseline technologies for geosynchronous orbit. The company aims to aid the Air Force Research Laboratory and SpaceWorks in meeting their goals of increasing mission flexibility and a swift adaptation to evolving operational needs, and continue enhancing the system's performance envelope for the upcoming Victus Haze mission and beyond. SES Space and Defense announced the successful demonstration of the first multi-orbit, multi-band commercial space relay service in support of the NASA Communications Services Project. SES Space and Defense partnered with Planet Labs, using SES's O3b mPOWER satellite constellation in medium Earth orbit, and Planet's low Earth orbit flight representative terminal for the demonstration. The demo showed a stable data link, validating hardware, data flow, and the end-to-end system performance, as well as successfully reduced flight hardware and services risk. The demonstrations support NASA's funded Space Act agreement, which enables commercial space relay via geostationary C-band and medium Earth orbit Ka-band satellites to spacecraft in low Earth orbit. The initiative allows for NASA's transition from the Tracking and Data Relay Satellite System, also known as TDRS, to commercial systems for its space relay requirements, while helping create a commercial market for space relay. Slingshot Aerospace has partnered with the U.S. Defense Advanced Research Projects Agency, also better known as DARPA, to successfully create a new artificial intelligence system that identifies anomalous spacecraft within large satellite constellations. The system has been trained on over 60 years of simulated constellation data. Slingshot's program, which produced the new AI system, began in March 2023, and the results were delivered to DARPA on January 2024. Slingshot is now focusing on implementing its new AI system and is engaged in ongoing discussions with the U.S. government and commercial space companies about methods for deploying this system as part of their advanced space domain awareness services. Black Sky Technology has been awarded a 1-year extension contract from the National Reconnaissance Office to continue to deliver on the current electro-optical commercial layer subscription contract for high-frequency Gen 2 imagery services. Brian E. O'Toole, who is the Black Sky CEO, says this contract represents continued confidence in Black Sky as a trusted mission partner as the NRO makes strides in leveraging commercial space technology to strengthen national security. And that concludes our briefing for today. Busy show today, huh? Head to the show notes for further information on all the stories that we've mentioned. We've also included announcements in there from NASA on awards for university research projects, a new partnership between SatView and Suhora, and details about Redwire's new payload facility. Hey, T-Minus crew, if you find this podcast useful, please do us a favor and share a 5-star rating and a short review in your favorite podcast app. It only takes a second, and it'll help other space professionals just like you to find the show and join the T-Minus crew. Thank you so much for your support and your help, everybody. We really appreciate it.
And now, a word from our sponsor, Zscaler, the leader in cloud security. Cyber attackers are using AI in creative ways to compromise users and breach organizations. In a security landscape where you must fight AI with AI, the best AI protection comes from having the best data. Zscaler has extended its zero-trust architecture with powerful AI engines that are trained and tuned by 500 trillion daily signals. Learn more about Zscaler Zero Trust Plus AI to prevent ransomware and AI attacks. Experience your world secured. Visit zscaler.com/zerotrustai.
Today's guest is Paul Bagdanove, Webb Telescope Mechanical Systems Engineer at KBR. Now, Paul has been a contractor for NASA for a number of years, and he walked us through his experiences.
I started on the Hubble Space Telescope with servicing mission 3B, and then, of course, on to servicing mission 4, and that was the last service mission to the Hubble. That's how I got my teeth cut were on the Hubble Space Telescope and the individual science instruments that were being built to replace the old instruments in Hubble. So from there, I lucked out and dove headfirst into the James Webb Space Telescope. Webb actually got started in 1996, and that was, of course, before I even got my job. But the fact is that you got to start somewhere with these satellites, and what they do is they start off with a concept. But if you look up what the concepts were back in the day, it looks similar to what the Webb looks like. But when I look at it, it looks completely different. I mean, it looks wild.
When you started, it was still, I think, wasn't the original launch date like 2004 or something like that? Obviously, that shifted a lot. But, I mean, when you started, it must have been, was it very different from what ended up launching, or was it the design pretty locked in at that point?
No. When I came along, the design was pretty much locked in. Some of the changes that happened were, minor changes, which were the sun shield. The sun shield was one of the more tricky developments. This new technology of deploying and unfurling this huge, we call it a gossamer structure, which is this lightweight. Just imagine trying to, just to maybe equate it to something that everybody's touched is silk. These silk sheets or these satin sheets. You're trying to fold it nicely, and then on command, open it up nice and have it just evenly open, smoothly open. You're not going to fold something like that easily, and you're not going to certainly mechanically unfold it easily. So that was one of the thorns in the JWST's side. So basically, the Webb took up the majority of my career so far. I spent roughly 17 years on the Webb Space Telescope. So that's going to probably be half of my career, depending on when I retire. And so the Webb was this amazing, in my mind, when I, heard about, what was going on with this science, I'm like, I really would like to work on that. And sure enough, I get to work on it. Once again, it's that luck that, I'm prepared, I can do the job. And they just said, hey, we would like you to work on this particular area. And of course, as we all do, we all contribute to the larger portion of what this big, monstrosity is going to be. And then they're like, well, I'm lucky enough to work on just this one little part.
I was going to ask, like, maybe it's too simplistic a question to ask, what components, what parts did you work on? If it sounds like you basically touched pretty much all parts of it. But are there specific areas where you're like, I definitely was more part of this, or anything where you're like, I really feel like part of me's in that?
Well, sure. There, of course, there's always stuff like that. So, as the contractor who develops and builds, I am not that person. What I am is a consultant, essentially, that says, well, yeah, they built it right. I look at their designs, I look at their analyses, and then if there's a hole, I fill that hole for the analysis. But for the brains of the Webb Space Telescope, that's a Goddard delivered portion of the telescope, and NASA always has some amount of control and build of aspects of satellites. The brains of the Webb Space Telescope is the ISIN structure. That's the Integrated Science Instrument Module. And so that I worked on exclusively with a small team. And that is something, just if I was only to work on just that alone, that is something to be proud of. We did thermal distortion of the science instrument module to make sure the stability and pointing of this science instrument met the requirements. And this pointing and control is super, super sensitive. So, you're testing all of these subcomponents, and you're doing all of this, and it's a composite structure made of carbon fiber and a particular type of epoxy with these metal joints. And so these metal joints have an influence. The tubes themselves have an influence. And we're making sure that the stability, and we're analyzing, we're doing it all by computer-aided design, if you will. And we use this finite element mathematical model to make sure that we are correlating test specimens, making sure that those correlated test specimens, when we take that information and dump it into our math models, the FEMs, the finite element models, then those things correlate to a larger scale. And then when we get to the larger test, we make sure that, once again, there's not much more that we have to do to scale and tweak those models to make sure that they are working as we've tested them. And so that's what I do. And I still do that to this day, where I make sure that these finite element models that we create to represent the spacecraft for that particular component or the spacecraft as a whole represent the thermal stability, the structural static loading for deflection, the pointing control stability when we do an optical pass, when we load it up in a particular manner, or we load it up for launch. We do these simulations, we load it for launch, things like this. And of course, our output that we see, we match to the test. And of course, the test is the real deal. These tests are not cheap, and they're not short in duration. Some of these tests are 30 days, months. It depends on depending on the level of which you're testing. And so you are just testing, correlating. And from there, we just took on the entire telescope, the whole system. And there was not a single system that we didn't put our hands on. But my main goal was the transportation and the isolation, and making sure that this satellite and all its subcomponents made it to the locations that they need for each individual test. And so my responsibility was mainly to get the telescope portion from Goddard Space Flight Center to Johnson for testing, and then from Johnson to Northrop Grumman out in California. And then that was to made up with the spacecraft. And then that entire spacecraft, once tested, put together completely, and was to ship from Northrop Grumman down to French Guiana, first by boat through the Panama Canal, and then into French Guiana, And then I was also responsible for doing vibe testing of the telescope portion, which is the Otis portion, the top with all the mirrors, that portion. And once we're there for Northrop Grumman, we do the vibe test of the entire satellite, and that's what we're responsible for. So in between vibe, we needed to thermally test the entire telescope, and they had to refurbish the old Apollo era thermal vacuum chambers, because we're such a huge telescope, such that the telescope portion could fit inside of a chamber, and we do thermal.
Yeah, I remember hearing about that. I was like, yeah.
And so I was responsible for that test as well.
Wow.
But I say me responsible, but as one of many hands, and just going through this whole entire thing. Then once we took it from transported from Goddard Space Flight Center down to Johnson Space Center. So we had to make sure that all the thermal testing was okay. And you're looking at it from a system perspective. So you're looking at all the subcomponents and everything that goes into it. And then you've got all these other sub teams that put all this stuff together. And, I just sit there once again and run simulations. And to me, it's the easiest thing. But it does take a lot of effort. It does take a lot of understanding.
All those simulations and all those tests, I mean, those are extremely important and, validating in literally the most literal meaning of that term. And it's to me always fascinating that these extraordinarily complex instruments like the Webb telescope have so many components in them that have been so rigorously tested. I mean, it's just absolutely amazing that when you drill in, like to the ISIM, as you worked on, how much work goes into that component. It's not a small component, obviously. It's just really fascinating to hear about.
Yeah, even for me, we're going to go into a test, and I'm like, I want to see what's going to happen in the test. I want to see what the setup is, and I want to make sure that whatever this representation that I made in my finite element model, this is what we're going to be putting into the chamber. I'm working on a new program right now, little small. It's called CAPE. It's a little small program, and it's got this little tiny, 8-inch by 6-inch diameter, little tiny science instrument. And I love it. I'm going to put accelerometers on it, and we're going to shake it, and I'm going to get some data from it, and I'm correlating it back to a model. So for me, yeah, I love it.
We'll be right back.
Don't struggle to align your organization's cybersecurity with business risk. Get the only solution that goes beyond reacting to threats with vulnerability and risk monitoring. You need the next evolution of MDR, and only Critical Start delivers it. Critical Start doesn't just monitor and respond to threats. They put you in control by detecting suspicious activities, quickly responding to contain threats, and identifying your most critical assets and protecting them against vulnerabilities and exposures. With continuous visibility, expert guidance, and measurable risk reduction, Critical Start has redefined what it means to manage cyber risk. Demonstrate provable security maturity to your leadership while positioning your program to achieve the greatest risk reduction per dollar spent. Stop fearing risk and start managing it with Critical Start. Visit criticalstart.com and request a demo today. That's criticalstart.com.
Welcome back. We all know, and we've all seen, the iconic image of the United States flag on the moon. It was planted there by Apollo 11 astronauts on July 20th, 1969. And that flag was made of nylon and had a crossbar on the top of the pole to help it stand without wind or an atmosphere. However, the astronauts had some trouble deploying the flag, and it's still a bit unclear if the flag remained standing after the ascent module took off. But we learn from our experiences, don't we? And roll forward some 54 years, and now we have a flag on the moon's far side, this time planted by the Chinese lunar probe Chang'e 6. But this is not an ordinary nylon flag. The The Chinese learned from the mistakes of the past, and they took a flag made of basalt fibers up there. Yeah, it is basalt. It is essentially made of rock. The National Space Science Center of the Chinese Academy of Sciences made this flag by crushing and melting the rocks in order to pull them into thin threads with a diameter of about 1/3 that of a human hair. And they believe that the final product could last over 10 millennia on the moon, as the material is highly resistant to corrosion, heat, and cold. Honestly, makes sense. The flag mission also serves another purpose. The materials used to make it could prove essential for construction of lunar bases in future missions. Only time will tell if the material can survive on the harsh lunar surface. Now, I should note that this is not the first time that China took a flag to the moon. During the Chang'e 5 mission, China also unfurled a flag made of composite material. For now, though, the Chinese flag is the only one on the far side of the moon, and its main purpose is to inspire patriotism amongst the Chinese people around the world, and maybe, possibly, to rattle a few cages amongst their adversaries. That's it for T-Minus for June 5th, 2024, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. This episode was produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazis. Thanks for listening. We'll see you tomorrow.
T-Minus.
Hey, listeners. We're always looking for ways to improve the N2K Cyberwire network and maintain the intelligence-driven news experience that keeps you in the know on the latest developments in cybersecurity. We've launched our 2024 audience survey and would love for you to take a few minutes to share your feedback. And hey, there's even a chance to win a $100 Amazon gift card if you complete the survey. Visit cyberwire.com/survey. That's cyberwire.com/survey and share your feedback now.